All right, so on to few more things in the epidermis. We have what are known as epidermal ridges. So if you look at this image here, right, so all of this is your epidermis, right? And this is the dermis down below. So you're seeing basically these ridges, right? Early on, they are produced, right? What they're going to allow you to do is they're going to increase that surface area. So the more surface area you have, the more gripping power you have via friction. This is the same principle that geckos use to climb walls, right? They have tons of little hairs on their pads. They get to climb walls because of all the friction. Let's see. It also will not only increase the surface for grip strength, but it also increases the surface area with which it makes contact with that dermis. Again, can't stress this enough. The dermis is the part of the skin that actually has the blood vessels that will feed the epidermis. So anything that increases the surface area will help increase the amount of food getting to the epidermis. Also, that increased surface area helps keep these two layers together. I kind of think of it as having like the difference between having two pieces of paper on top of one another, right? Those can slide real easy against one another. And what you don't want to have happen is your epidermis just kind of fall off on you, right? That's kind of, you see that in zombies and stuff. What you want is, imagine like having two egg cartons and you're sticking them together, right? Once you put two egg cartons together, those don't move, right? It's because of those ridges that you have inside. Very similar to that. Imagine it's like egg cartons. The other thing is these epidermal ridges, they're particularly pronounced in our fingers and in our toes. These are what gives us our fingerprints, these epidermal ridges. All right, so now let's continue on to the dermis. Oh, and I will kind of, nope, hi, that's not what I wanted. Get rid of me. All right. So dermis contains lots of different hair follicles, glands, nerves, blood vessels. Interestingly enough, and we'll talk a little bit more about this in a bit, but the hairs are actually an epidermal structure. So we'll take a close-up look at this, but the epidermis kind of dips it dips all the way down into the dermis, and that's what actually gives rise to your hairs. So it contains lots of these structures. When we look at them underneath the microscope, that's where we see them. Right? We'll see we have two different layers of the dermis. There's something called the papillary region and then the reticular region. The dermis, here's like a little bit of an aside. Like when you've probably either had a leather jacket or played with a leather ball or had leather shoes or belt or something like that. Anything that leather product that we see out on the market, basically what that is, it's the dermis of some other animal. So most of the time it's cows. Sometimes it's pigs, right? Pigskin footballs. So depending on what that is, sometimes it's lamb, sheep, whatever it is, it's the dermis of animals. That's what you're actually wearing. I don't know, that's kind of grossing you out or not, but that's what that is. It's actually animal dermis. All right. So let's just take a look at this papillary region. It consists of about the top 20% of the dermis. So here's the dermis. Let me just kind of change the pen color here. Good color. Does that show up? No, it's not showing up at all. Let's see, pen color, maybe a blue? I don't know if it's any better. But it's about the first top 20% of your dermis right in here is going to be the papillary region. It consists of areolar connective tissue, and it has these dermal papilla. So when we kind of remove the epidermis from the dermis, so again, kind of imagine like those two egg cartons, right? You see this part that's sticking up, those are called dermal papilla. Again, helps anchor to the epidermis, has all these capillaries, again, help feed the epidermis. And if you remember back to lab, you'll see all these Meissner's corpuscles located You can see these little yellow guys right here. Those are also located only in that dermal papilla. That's where they are found. So in each one of these dermal papilla, chances are you're going to find a Meissner's corpuscle. We'll also see other nerve endings, and these are considered free nerve endings because they don't have that sort of capsule around them that like the Meissner's does. They're just bare. There's nothing around them. Nerves, and those will pick up on things like heat, cold, pain, tickle, itch. And for the most part, they can only transmit one type of information at a time. So for example, when these bare nerve endings, if something itches, right, that's the information it's going to convey. So if you ever had a mosquito bite sting and someone tells you like, oh, use your nail to put like an X on top of it, it'll stop itching. What you're basically doing is that you're introducing pain. So by introducing pain, the itching stops because it can only convey one type of information at a time. So that's why the itching goes away. And if you haven't done that, try that next time. Right. So underneath that papillary region, so the remaining 80%, is going to be this reticular region. So it's a vast, that's a vast majority. So basically the rest of this, it's like all of this area in here, right? So all of that is going to be our reticular region. Connective tissue type changes, so it goes from areolar connective tissue to a dense irregular connective tissue. So it has lots of collagen, elastic fibers, it gives it strength, elasticity. Right? And as we can see, it has lots of oil glands, sweat glands, there's some fat, and our hair follicles will be located down in here. So one of the things that, let's see if I can get my pen back. One of the things that these elastic and collagen fibers are going to do is they're going to give this reticular region two different characteristics. One of them is something called extensibility. So basically what extensibility means is that it has an ability to stretch. It's extensible. I can stretch it. But another key thing is that it's also going to have elasticity, and those are two different things. Elasticity. And this means that it has the ability to return to its original shape after stretching. Okay. So it's extensible and elastic. Those, again, two different things. And this is how I tell people to keep them separate. Think of gum versus a rubber band, right? If I have a piece of gum in my mouth and I kind of hold it with my teeth and I use my fingers to pull it out, it is clearly extensible. I can stretch that. However, it is not elastic. It will not snap back and hit me in the face, right? Now, if I held a rubber band in my teeth and pulled it out, clearly it's extensible. I can stretch it. Now, if I let go of that, it's going to hurt. So that, in that case, it's also elastic, and that's how you differentiate between the two. So there are two different types of characteristics that some things can have. Sometimes they have one, sometimes they have the other, sometimes they have both. Okay? All right, just what I told you guys. Oh, and I'm sorry, I kind of wrote over this. I don't know how you'll see this. Stretch marks. We've all had the joys of stretch marks somewhere in our bodies, right? What ends up happening is that basically it's going to be similar to what a scar is. Now, a scar, you're going to damage the epidermis and the dermis, and you have blood and stuff like that, kind of forming a scab. And when the skin tries to repair itself, it repairs itself a little bit different than what it originally was, and so you have a mark, right, along that cut line. A stretch mark is very similar, except in this case, the epidermis didn't tear, only the dermis did. So the dermis fixes itself, And usually it'll try to fix itself a little bit stronger, sort of kind of like we talked about just in the previous video about like how the epidermis will grow a little bit thicker where you kind of keep irritating and form calluses and stuff. Similarly, if you've torn the dermis, it'll try to fix itself a little stronger. Anyway, where it fixes itself a little bit stronger, usually you don't see blood vessels there. Sometimes you do, sometimes you don't. And so what ends up happening is that sometimes the stretch marks look white. There's like a little bit of a dip because things have moved apart. They don't necessarily, when it heals itself, it doesn't heal itself as tightly as it once was. So that connection, pulled apart and stays pulled apart. So you get kind of like that little divot down in your stretch marks. All right, let's talk about tattoos. I love tattoos, so one of the things that I like to talk about. Plus, pretty much we all know someone or who has a tattoo, or we have tattoos ourselves, right? So basically, when you get a tattoo, what the individual the artist is trying to do is inject the pigment into your dermis, right? Let's think about this. Now, if they put it in the epidermis, would it be permanent? No, right? Because again, as we mentioned just in the previous video, you're constantly losing your epidermis. So, like a henna tattoo stains the epidermis, and then after a few weeks, it's gone. Right? It gets lighter, 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 because all those cells that were dyed by the henna, as they flake away, right, there's less ink, or less dye, I should say, and then basically, you don't see it anymore for a while. Now, our conventional tattoo, we go to the tattoo shop and they actually use needles and they inject it into the dermis. That stays because we do not slough off our dermis. Okay, so that's what they're trying to do. They're trying to get it into that dermis. Now, if they get it too far down, it goes into subcutaneous, and in that fatty area, it really tends to bleed, right? If you get it too far down, there's also lots of, well, it just tends to bleed more. So by bleeding, I don't mean blood bleeding. I mean like it doesn't stay as a nice crisp line, right? It kind of looks more smudgy. It's not as crisp. Especially over time, the body will try to kind of move that ink, but the ink is a fairly large molecule, so it can't always clear it very well. But the further down you go, you have larger vessels that can. So again, it's a little more fuzzy looking. So a really good artist will know just how deep to go. Okay. I'll let you guys watch this video on your own time. It's basically a YouTube video. It's sort of like my PSA to students. It's on a product called Dermal, and we may, all of us at some point, find ourselves in a job where they won't allow you to show tattoos. So if you ever have to cover it up, this Dermal stuff works really well. I actually have had students who've used it in the past, and if you're, it's kind of like how good a makeup artist are you? But if you're good at it, or get good at it, I guess, you really can't even tell that the individual has a tattoo, even if it's like a tribal black tattoo kind of thing. So anyway, so you can watch the video. It's kind of cool. It's only a few minutes long. So I kind of just have some images of tattoos. I just thought they were kind of fun. Did a quick little internet search. People get kind of clever with stuff, right? Oh, here's my other PSA. If you're going to get lettering, spell check. Especially if you're going to have like a message like that. Okay. Yeah, I like it. That's kind of neat. Anatomy one. And then there's this guy. So he's actually in the video. I don't know if y'all are familiar with him. He's sort of like, I don't know, stage name, I guess, is Zombie Boy. And so this is an early image of Zombie Boy before he became all zombified. Right? You may have seen him in Lady Gaga videos, and he's been in a movie or two now. So that's him now. And again, he's in that video. So he looks sort of like what he looked like before he had tattoos, and then you'll see how good that Dermal stuff works. Anyway. All right. So let's talk about some other things. So we mentioned our skin tells us a lot about our health and conveys lots of information to individuals around us. So one of the things that you notice when you look at someone is basically the color of their skin. So the term jaundice basically means that there's a yellowish color to the skin and sometimes even the white of the eyes. And what happens is that this results in a buildup of a product called bilirubin. Now, bilirubin is a byproduct of red blood cell breakdown, and your liver does a good chunk of the job of breaking down old red blood cells and recycling them. And again, one of these byproducts is this thing called bilirubin. So if your liver is not functioning properly, it can't further break down this bilirubin or process it, so it ends up building up in your bloodstream. So that's what you kind of start seeing. This individual actually looks sort of jaundiced or yellow. Sometimes babies are born yellow with jaundice, mostly because their livers aren't functioning quite at the level that they need to be. Fortunately, bilirubin is fairly photosensitive, meaning that you put it out in the sun and it'll start breaking down. So they'll put babies under like UV lamps, or different kind of light treatment or whatever they call that, and basically it'll help break down the bilirubin in their skin, and it'll just clear that yellow color until the liver can start functioning at full capacity. Cyanosis is another term. Sometimes individuals will get a bluish color in their nail beds or even their skin. Basically what's happening is that the hemoglobin is being depleted of oxygen. So you get this sort of purple-blue. So here you can kind of see here's a child that I don't know exactly what's happening here to this individual, but you can kind of see the blue around the lips and right at the fingertips, right at the very extremities. Okay, very dangerous. Okay, basically that means they need oxygen, they need it now. Okay. And erythema is just a very blanket term. You can kind of see here's an example of erythema, and it looks like the individual has, to me it looks like a little mosquito bite. All erythema is simply redness of the skin. It's not telling you why, just redness of the skin. So in this case, it may be due to inflammation. Well, not in this case, but it could be you have some sort of inflammation and infection. It could be because you have an allergy. So again, you're allergic to a mosquito bite. Perhaps you burned yourself, right? So it could be due to a number of different things. It simply means there's redness in the skin.